Bismillahirrahmanirrahim. Assalamu alaikum students. Mubashir Aziz is here. Our today's topic is product of vectors. इसमें हमने ये note करना है कि how vectors can be multiplied. So there are two types of product of vectors. First one called scalar product or dot product, whereas other type is vector product or cross product. So these are two types of product of vectors. So what is scalar product? And what is difference between scalar product and vector product? So here scalar product, the product of two vectors which results in the form of a scalar quantity is called स्केलर प्रोडक्ट, जिसमें हम दो वेक्टर्स को अगर मल्टीप्लाई करते हैं और उनका रिजल्टेंट हमें स्केलर क्वांटिटी की सूरत में हासिल हो, देन सच अ प्रोडक्ट इज कॉल्ड स्केलर प्रोडक्ट. व्हाई इट इज कॉल्ड डॉट प्रोडक्ट? हम इसको डॉट प्रोडक्ट क्यों कह रहे हैं? व्हाई स्केलर प्रोडक्ट इज आल्सो नोन एज dot product. For this purpose, consider there are two vectors A and B making an angle theta with each other. So these are two vectors, vector A and vector B, making an angle theta with each other. So their scalar product can be written as A dot B. A dot B. इसको आप पढ़ेंगे भी ऐसे ही A dot B. That's why scalar product due to this symbol is known as dot product. So scalar product is also known as dot product. So what is its mathematical form? So here two vectors A and B making an angle theta with each other. So it's a dot product. A dot B can be written as magnitude of first vector, which is A, and into projection of second vector in the direction of first vector. Here second vector is B and the first vector is A. So magnitude of first vector into projection of B in the direction of first vector, that is A. So here its projection of B can be determined as, this is X projection or X component of vector B, known as B cos theta, and the projection along Y axis is known as B sin theta. But according to the mathematical form, we have to choose that component which is in the direction of vector A. यानी हमें इन दोनों कंपोनेंट्स में से B cos theta और B sin theta में से वो कंपोनेंट यूज करना है जो वेक्टर A की डायरेक्शन में हो, and that is only B cos theta. So its mathematical form becomes A dot B is equal to A, which is magnitude of first vector, into B cos theta, which is projection of vector B in the direction of vector A. Hence A dot B is equal to AB cos theta. So this is mathematical form of scalar product. A dot B in magnitude form can be written as AB cos theta. Similarly, if we change the order of multiplication, यानी अगर हम ऑर्डर ऑफ मल्टीप्लिकेशन चेंज कर देते हैं, पहला हमारा वेक्टर B है, दूसरा वेक्टर A है, देन डॉट प्रोडक्ट B dot A is equal to magnitude of first vector. Now first vector is B into projection of second vector, which is A, in the direction of vector B. So again, by resolving vector A into its rectangular components, here A cos theta is the X component of vector A, X component of vector A, and A sin theta is Y component of vector A, which is opposite in direction of angle theta. Theta के सामने हमेशा Y component होगा, theta के साथ हमेशा X component होता है. So here A cos theta is the X component of vector A, and A sin theta is the Y component of vector A. So mathematically it becomes B into A cos theta. A cos theta is in the direction of vector B, and according to condition हमें वो projection use करना है जो vector B की direction में होगा, and that is A cos theta. So B dot A is also equal to AB cos theta. B dot A is also equal to AB cos theta. So here are some examples of scalar product. For example, work done. We know that work is a scalar quantity, but it is dot product of two vector quantities where first quantity is force and the second quantity is displacement. According to physics, work is done when a constant force is applied on a body and it covers some displacement in the direction of applied force. So here W is equal to F dot D. So let me suppose there is a block which is lying on this horizontal surface. It has to be displaced towards right. हम इस ब्लॉक को rightward shift करना चाहते हैं. So displacement covered of the block would be due right, whereas the force is being applied along string. एक रस्सी के जरिए इस ब्लॉक को बांधा हुआ है और उसके जरिए इसको खींचा जा रहा है, तो फोर्स अप्लाई की जा रही है string के along. But displacement covered is along horizontal. So there is an angle theta between force and displacement. Force और displacement के दरमियान angle theta है. To solve this problem, we have to resolve force into its rectangular components. So here F cos theta is the x component of force F, which is in the direction of displacement. And F sin theta is the y component of force F. Y component of force F. And according to the scalar product, we have to consider that projection which is in the direction of the first vector. So here W becomes equal to F cos theta, because F cos theta is the x component of force F and it is in the direction of displacement. So W becomes equal to F d cos theta, where d is displacement, F cos theta is the projection of force F in the direction of displacement. So W is equal to F dot D is vector form, and W is equal to F d cos theta is the magnitude form to determine the magnitude of work done. There is another example for P, which is equal to F dot V. Here P is for, and F is force, V is velocity. We know that force and velocity both are vector quantities, but power is a scalar quantity. So P is equal to F dot V. Third example is in the form of electric flux. Electric flux that is equal to E dot A. Here phi E is electric flux. E is electric field intensity and A is vector area. So electric intensity and vector area both are vector quantities, but their product is in the form of a scalar quantity known as electric flux. So when we multiply two vectors and their resultant is in the form of a scalar quantity, then such a product is called scalar product or dot product. Let me discuss some characteristics of scalar product or dot product. So here is the first characteristic, that is commutative property. इसमें हमें ये चेक करना है क्या ऑर्डर चेंज करने से, मल्टीप्लिकेशन ऑर्डर चेंज करने से रिजल्ट पे फर्क पड़ता है या नहीं पड़ता. So here is A dot B, which is AB cos theta. A dot B is equal to AB cos theta, and we also know that B dot A is also equal to AB cos theta, which means that A dot B is equal to B dot A. A dot B is equal to B dot A. यानी अगर हम इसका मल्टीप्लिकेशन ऑर्डर चेंज कर देते हैं तो रिजल्ट पे फर्क नहीं पड़ेगा. So A dot B is also equal to B dot A. Hence scalar product or dot product obeys commutative property. So this is first characteristic of scalar product. Characteristic number 2, when there are two parallel vectors. So let A and B are two parallel vectors. Then their scalar product or dot product becomes A dot B is equal to AB cos theta. Since they are parallel to each other, so angle between them is equal to 0 degree. Since they are parallel, so angle between them is 0. So A dot B is equal to AB cos 0. And we know that cos 0 is equal to 1. So A dot B becomes equal to the product of magnitude of both vectors, that is A into B, where A is the magnitude of first vector, B is the magnitude of second vector. Hence, when two vectors are parallel to each other, then their scalar product becomes equal to product of their magnitude. In terms of unit vectors, we know that I, J, and K are unit vectors along x-axis, y-axis, and z-axis respectively. So in terms of unit vector, their scalar product, I dot I, since I is always along x-axis, so angle between I and I is equal to 0 degree. We know that magnitude of unit vector is 1. And cos 0 is also equal to 1. So I dot I becomes equal to 1. So scalar product of two similar unit vectors is equal to 1. Similarly, in terms of J dot J and K dot K, that is also equal to 1. Characteristic number 3. If there are two perpendicular vectors, so let there are two vectors A and B making an angle of 90 degree with each other. In case of perpendicular vectors, again we know that A dot B is equal to AB cos theta. Since angle between them is equal to 90 degrees, so A dot B becomes equal to AB cos 90 degree. AB cos 90 degree, where cos 90 is equal to 0. So dot product of two perpendicular vectors is equal to 0. In terms of unit vectors, we know that I, J, and K, they are mutually perpendicular. They are right angle to each other. They are perpendicular to each other. Hence, I dot J, by putting angle that is equal to 90 degree, magnitude of unit vector is 1, so cos 90 is equal to 0. So I dot J becomes equal to 0. Similarly, J dot K as well as K dot I is also equal to 0. So whenever there are two perpendicular vectors, their scalar product or dot product becomes 0. Number 4, when two vectors are antiparallel, when two vectors are in opposite direction, then angle between them is equal to 180 degree. So their scalar product AB cos theta becomes AB cos 180 degree, since they are opposite in direction. So A dot B is equal to AB cos 180 degree, and cos 180 is minus 1. Hence A dot B is equal to minus AB, negative of the product of the magnitude of both vectors. So A dot B is equal to minus AB. Characteristic number 5, self product. When a vector A is multiplied with itself, जब इसी वेक्टर को हम इसी के साथ मल्टीप्लाई करेंगे, when a vector A is multiplied with itself, then self product A dot A can be written as A cos theta. So in case of self product, angle between A and A is 0, because we know that according to the condition of equal vectors, two vectors are said to be equal if they have same magnitude and same direction. तो A और A दोनों सेम उसी सूरत में हो पाएंगे if they have same magnitude and same direction. Since angle between both vectors is equal to 0 degree, so A dot A becomes equal to A into A cos 0 degree. Since cos 0 is equal to 1, so dot product becomes equal to square of its magnitude. Square of its magnitude. So this is characteristic number 5. Now there is final characteristic number 6, which is very important. Scalar product of two vectors in terms of their rectangular components. इसमें हमें दो vectors को मल्टीप्लाई करना है बट बाय यूजिंग देयर रेक्टेंगुलर कंपोनेंट्स, इनके रेक्टेंगुलर कंपोनेंट्स की हेल्प से. लेट वी हैव vector A whose components are AXI plus AYJ plus AZ K unit vector, whereas vector B having components BXI plus BYJ plus BZ K. Then their scalar product A dot B can be written as the components of vector A dot the components of vector B. इनको मल्टीप्लाई करने के लिए आपने इसको इस लिहाज से ऑपरेट करना है कि if there is a term of x component of vector A, then multiply this component with all components of vector B in such a way. Here ax into bx, any x component of vector A and x component of vector B, and their unit vectors can be written as I dot I plus ax into by, यानी वेक्टर A का x component और वेक्टर B का y component, and the dot product of their unit vectors I dot j. Similarly, ax bz into I dot k. Now it's turn of y component of vector A. अब आपने वेक्टर A के y component को वेक्टर B के तमाम components के साथ बारी बारी मल्टीप्लाई करना. ay into bx j dot I plus ay into by j dot j plus ay into bz j dot k. Now it's a turn of z component of vector A. So az bx k dot I plus az by k dot j and az bz k dot k. So after multiplying both vectors in terms of their rectangular components by putting the values of I dot I dot j, j dot k dot I, we know that the value of I dot I, j dot j and k dot k is equal to 1. जिसको यहाँ हाईलाइट किया गया है, रेड कलर में है. Their value is equal to 1. Their scalar product or dot product is equal to 1. But in case of two perpendicular unit vectors, dot product is 0. So A dot B is equal to AX BX. Value of I dot I is 1. AX BY, value of I dot J 0. AX BZ, value of I dot K is also 0. AYBX, value of J dot I is 0. AYBY into J dot J, that is equal to 1, plus AYBZ J dot K is 0. Similarly, AZBX K dot I is 0. AZBY K dot J is 0, plus AZBZ K dot K is also equal to 1. Finally, the scalar product of two vectors in terms of their rectangular components is equal to AX BX plus AY BY plus AZ BZ. So this is scalar product of two vectors in terms of their rectangular components. Thank you very much.